Hi, so now we're looking at section 1.2, which is titled Observational Studies versus Design Experiments. So objective 1, we want to be able to distinguish between an experiment and an observed study. Okay? So just a quick recall from section 1.1, we looked at this list, the process of statistics. And you can see currently this section we're going to be dealing with number 2, which is collecting the data needed to answer the questions posed in step 1, right, in the process of statistics. So you can see here, after you've determined your research objective, the next step is to develop the methodology for obtaining the data. Okay. So there are two methods for collecting data. One is an observational study, and the second method is designing an experiment, right? So designed let me rewrite that, experiments. Alright, so next I would like you to consider the following two studies. So if you would pause the video and read over study 1 and also read over study 2. Right, so read those over in your notes. Alright, so now that you've read the two studies, we want to look at some things. So I have here a statement. So in both studies, the goal of the research was to determine if radio frequencies from cell phones increase the risk of contracting brain tumors. Right? So whether or not brain cancer was contracted is what we call the response variable. Right? The level of cell phone usage is the explanatory variable. So in research, we wish to determine how varying the amount of an explanatory affects the value of a response variable. Right? So essentially, we're trying to have this explanatory variable vary the amount to see what happens to the response variable, right? How it responds, right? Might help you remember that, right? We're trying to use this variable to explain that response, right? So that's where the explanatory response words come from. So an observational an observational study measures the value of the response variable without attempting to influence the value of either the response or the explanatory variable. That is, in an observed study, the researcher observes the behavior of the individuals without trying to influence the outcome of the study. If a researcher randomly assigns the individuals in a study to groups, intentionally manipulates the value of an explanatory variable, and controls other explanatory variables at fixed values, and then records the value of the response variable for each individual, the study is a designed experiment, right? So those are the two definitions for observational studies and design experiments, right? And something to keep in mind is that some people might think that a design experiment is better than an observational study, but you can't necessarily say one's better than the other, right, necessarily. So obviously a design experiment would be ideal, but there are certain cases that we can't have a design experiment because of maybe ethical reasons. So, for example, looking at these two studies, we can determine which one was observational, which one was design experiment. So part B, study number 2 was the design experiment, and study number 1 was the observational study, right? And you might, when I said explain, right? So, for part A, right, there was no attempt to influence the value of the explanatory variable, which is radio frequency exposure or cell phone use, right? So since there was no attempt made to influence that value of the explanatory variable, that's why we have an observational study, right? We're basically just kind of sitting back and seeing what happens. However, in study number 2, right, the researchers manipulated the value of the explanatory variable, which was radiation, and they tried to control other variables like temperature of food. That was a designed experiment, right? So in this case, we used rats instead of humans because it's not very ethical to expose humans to radiation to see if brain cancer is caused, right? So you can imagine why there's be some ethical issues with that, right? So another example would be, if I wanted to, research the amount of recovery time for someone that has broken their collarbone, right? It'd be unethical for me to do is design an experiment in that, right? I can't just randomly assign, people in my sample, like you're going to be the control group, and this group, we're going to break your collarbone, and I think things of that nature. That doesn't seem very ethical, right? But if I was doing an observational study, I might be able to happen to find people that had broken their collarbone and just kind of observe and see what happens, and try to come up with that. So there's some different options for that, right? So one's not necessarily better than the other, but something that we're going to find is the type of conclusions we can make are they're a little different between observational studies and design experiments, right? All right, so another example is looking at flu shots and how, maybe they benefit seniors. So I'll have you pause the video and read over this example. All right, now that you've read over that example, part A just asks a question, based on the results of the study, would you recommend that all seniors go out and get a flu shot, right? So, might be thinking, it looks promising, right? So, might be thinking that this looks promising. Right. However, you can see here that this study may have flaws, and there's an idea we need to talk about called confounding. So you can see here, confounding in a study occurs when the effects of two or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable may be due to some other variable or variables not accounted for in the study. All right. So another thing that we want to list is called a lurking variable. So a lurking variable is an explanatory variable that was not considered in a study, but that affects the value of the response variable in the study. In addition, lurking variables are typically related to explanatory variables considered in the study, right? So we have this issue of confounding, and one type of confounding is this lurking variable. So we want to state some potential lurking variables that were in the study, right? So here are some that we can think of. Maybe race is a potential lurking variable. Maybe income. Gender could play an effect. that wasn't accounted for. Maybe just overall health. So, maybe patients that happen to get a flu shot are, typically more healthy. Also, another one that you might think about is what we call functional status. Right? And what I mean by functional status is the patient's ability to, complete like day-to-day activities on their own. Right? So, being able to bathe yourself, make yourself dinner, just those real typical day-to-day things could also play an effect here. Right? So, kind of understanding, some different things that affect seniors would, be helpful here. I guess another thing kind of related to functional status that could affect this is maybe mobility. Right. So how are the patients, can they easily get around, or is it really hard for them to get around, or maybe they have no mobility, they can't really move on their own, right? Kind of related to functional status. All right, so the top of the next page, it says even after accounting for potential lurking variables, the authors of the study concluded that getting an influenza shot is associated with a low risk of being hospitalized or dying from influenza. Right? So I want to pay attention to that associated variable. Right? So saying two things are associated doesn't mean causation, right? And that's what this next sentence is saying, right? Observational studies do not allow a researcher to claim causation, only association, right? So saying two things are associated does not mean that one thing causes the other, like cause and effect, right? That's causation. So it's important to understand the difference, because two things could be associated, but it doesn't mean one thing causes the other, right? So for example, maybe wearing a red shirt on the day of the final exam and your percent received on the final exam seem to be associated by one another, right? So, but certainly that would not imply that if you wear a red shirt, it's going to cause you to do better on the exam, right? So there could be an association like that, but it doesn't mean that one thing causes the other thing to happen, right? So that's maybe kind of a silly example, but just to so you can understand the difference. Where if we looked at like ice cream sales and the temperature outside, that would be, maybe likely that the temperature outside causes you to buy more ice cream, right? I mean, typically, if it's really hot out, like 102 degrees or something, you might be more tempted to buy a cold treat to cool you down, versus if the temperature was like negative 10 degrees outside, you might not be interested in ice cream. Maybe you want a bowl of chili or something, right? So that's just to kind of give you an idea. So the next sentence I have here, so while lurking variables tend to exist in observational studies, confounding variables tend to exist in design experiments. Right? So you want to note that, right? So in other words, lurking variables, observational studies; confounding variables, design experiments, right? That's what typical, right? And here's a definition of confounding variable. So a confounding variable is an explanatory variable that was considered in a study whose effect cannot be distinguished from a second explanatory variable in the study, right? So I want to just make a few notes here before we move on to objective 2. Oops. Sorry about that. Let me... All right. All right, so maybe I'll just write it here. I was going to go off to the side, but it's not seeming to want to. So I'll just make a bullet point here. That is that lurking variables are not considered in the study, right? Where confounding variables are measured study. Right? So I know that you don't understand the difference between lurking variables and confounding variables might be a little hard, so that's just one way to kind of help you see the difference. If you read in the text, it has a good example with confounding variables. So I'm trying to remember. I think it goes something like there's a professor trying to see if using like my math lab benefits student scores, like their final course grades. So what he does is there's a morning section of his class, and he uses my math lab in that class, and then the afternoon class does not use my math lab, use like paper pencil homework, and then compares those two groups to one another. Now, a variable that, a variable that's measured in this study, but is like a second explanatory variable that could be affecting, could be affecting the response variable. In this case, would be time of day, right? So it was planned on, it was designed in the study that you'd compare morning to afternoon class, but it's possible that maybe the morning students are more like go-getters, and so they might just naturally do better in the class, right? So it's hard to tell if that's what's going on, or if my math lab homework system is really what's influencing that, right? All right, so objective 2 is being able to explain the various types of observational studies. So there are 3 major categories of observational studies that we'll look at and have some examples here. So a cross-sectional study is an observational study that collects information about individuals at a specific point in time or over a very short period of time. Right? So then case control studies is another type, and these studies are retrospective, meaning they require individuals to look back in time or require the researchers to look at existing records. In case control studies, individuals who have certain characteristics are matched with those who do not. And then lastly, we have cohort studies. So a cohort study first identifies a group of individuals to participate in the study. The cohort is then observed over a long period of time. Over this time period, characteristics about the individuals are recorded. Because the data is collected over time, cohort studies are prospective. Right. All right, so what I have left, what's next is looking at an example, and we want to determine, so we have 4 studies, and we want to determine if the following studies are observational study or an experiment, and then if it's observational, we want to determine the type of the observational study. All right, so if you would, pause the video, and I'd like you to read over A through D, and then I'll go over the results with you. All right, so after looking over A, kind of the key thing here is that we were looking at something during World War II, right? So it's past its former. So we had and we're comparing it to a control group of 43 people, and also we're not trying to control any type of variable. the explanatory variable. So this, I think, reading over that, you should easily see this is an observational study. Right, and then the key again is that this is like looking at records in the past and comparing it to like a control group. So this would be a case control study. All right, so then looking at part B, kind of the thing that sticks out is you have 75 children who are given milk with and without this drug. And so this would be a design experiment. Right, because we're controlling we're trying to control and see, test what's going on. And then part C, reading over that, you should see that's an observational study, and this would be a cross-sectional study. Right, so the key thing there is that we're looking, like doing a survey to get a specific point in time. Right, so this would be observational study. Say cross-sectional study. Right, and lastly, reading over that, you should conclude that this is observational study. And it's a cohort study. Right. All right, so the next item we want to talk about is called a census. So I have here a definition in that box. So a census is a list of all individuals in a population along with certain characteristics of each individual, right? So you've probably heard the term census before and could probably come up with a definition like that. So we do, the U.S. Census every 10 years. And the goal of that is to learn the demographic makeup of the U.S., and it impacts a lot of governmental type things, right? So I have listed here some. For example, the number of representatives in the House of Representatives for each state is determined by the census. The congressional districts is determined by the census. Distribution of government funds, such as Medicaid, is impacted with the census. And then also that data is used for planning purposes, for constructing, new schools and also roads. Right. So to give you some stats to give you an idea, the cost for doing a census. So the cost of doing the U.S. Census in 2010 was roughly $5.4 billion, right? And it employed roughly 635,000 people, right? So $5.4 billion and employed roughly 635,000 people, right? So, these were temporary workers helping collect the data and things. So that's expensive, right? So we talked about before, why do a sample? Well, one reason is that it's super expensive to do a census, which is gather information about everyone, right? And also, theoretically, the U.S. government should be able to do a census and get information on every single person, right? They should be able to require it, and people just do it. However, the U.S. government cannot collect information on everyone, right? There are some difficulties there. Some reasons why that might happen are illiteracy. So someone who can't read and write, they probably don't fill out the census, right? they would have trouble with doing something like that. Also, there might be some language barriers, such as if your English is a second language, right? So maybe you primarily speak Spanish in your home, and trying to fill out the U.S. Census in English just doesn't really work well for you, right? Maybe you're homeless, right? So, typically the U.S. Census is sent to your home address, right? And where's your home address? Where does that come from? My guess would be from your taxes, right? You submit a tax paper to the IRS and you give them information that way, and I would guess that's how the U.S. finds out where you live, right? Or maybe from like License Bureau, right? There's different ways to figure that out. I'm not entirely sure where they get that, but I would say something along those lines. Also, we might have some people that are here that don't want the government to know that they're here, right? So maybe you're an illegal alien, right? So you're in this country illegally. You don't want to be found, right? So it's hard to track all of that, right? Because the U.S. Census is trying to gather information on people who live in the U.S., not necessarily U.S. citizens, right? Although U.S. citizens do live here, right? They want to capture the information for everyone. All right. So then the last part of this section to talk about is an idea called web scraping, and this is something that's really been booming. In the last 10 years or so. You might have heard terms like big data and things, and this is some new territory, and there's actually a lot of money in this if you ever became interested to study like big data and statistics. But you can read here that web scraping, or what we call data mining, is a process where we try to extract data over the internet. So web scraping can be used to extract data from tables on web pages and then upload it to a file, so we can use that and do some analysis work. Or it can be used to create a data set of words from an online article. Web scraping is becoming an important part of the data science industry because data is so valuable to companies looking to make improvements. Web scraping packages are being developed continuously with programming languages such as Python and R. Right, so Python and R are both programming languages, as it said. Python's pretty popular, and so is R. And we use R in this class as a statistical tool. Right, you can do a lot with R. But when we're using R, we're going to be coding along the way. So I'll be helping you with how to use that. Right. So this idea is, we create like this algorithm that looks for this information, pulls it from the internet, and gives it back to us like in a file format that we can manipulate and work through. Right. So there are some pros and cons from this. So I was able to come up with 5 pros and 5 cons for data mining or web scraping. So one pro is that it's good for studying, like price changes, sold out items over Black Friday. Right, so that's a pro. Maybe for a company, maybe they're trying to estimate how many items they need, or all different kinds of things, right? Another pro is it allows companies to learn more about their customers. right? So, the more you know about your customers, hopefully the more you can get them to buy and see their spending habits and things, right? So obviously companies would be interested in that information. Another pro, maybe something you recently tried to buy a home, you might have come across or try to use. So realtor websites with home price estimates algorithms. So a common one is Zillow.com, right? So maybe you've checked out this website. If not, you can check it out. Look at maybe a home in your neighborhood or even your own home, and it'll try to come up with some kind of estimate for how much you might be able to sell your house for, right? Or buy it for. And that uses current the current housing market to help determine that. So the number 4, something else maybe you've used is it can help you with finding a job, right? So these are things might scrape and try to find job posts on websites and try to match you with that job, right? So search job postings. And match applicant with the job. Right, so one example of this is LinkedIn. I'm sure you've probably heard of that site before. Lastly, another pro is that they can rank sports teams with ranking algorithms. So one example of this is called StatCast. Right. All right, so then now for some cons. So one big con is that this web scraping is done without permission of the host. Right? So, if you host a website, you make a website, you post information on it, this is going to pull information off your website, and maybe you don't want your information being used in that way, right? Another thing you could think about is it also doesn't have the permission of the person who that information is about, right? So maybe some of my personal information is on some web page. Is that do I own that? Can companies just grab that and use that for their own good, or should they have to pay me for it? Right? There's a lot of things around that, like around if you've ever watched like any of the court proceedings with Facebook and different companies of that sort around owning people's data about people and selling that for companies and making money off that, right? There's a lot of issues around that, right? So number 2 is it legal, right? And we're not really sure. I think we're still trying to figure that out, right? Another con is it ethical, right? We don't know, but lots of companies are making big dollars off of it, just like Facebook, right? That's why they make that free web page that you can share stuff on. You're giving them your information. Right? Number 4 is that your personal information could come from a purchase. All right, so in other words, people could get your personal information. Lastly, is it creepy, right? So for example, you go on Amazon.com and maybe you're, I don't know, looking to buy a new novel to read. And then maybe you go to Facebook and you keep seeing ads for that novel that you searched for in Amazon. That's kind of creepy, right? So that could certainly be a con. Right? All right, so one programming language that you could do web scraping with is R, and like I said, we're going to use that. There's a lot of data out there that we can download as a CSV or a TXT file. Those are common file formats that you can save and upload into a statistical package like R or SPSS or SAS, SAS, things like that, or Minitab. So what I want to do now is, first of all, I want to show you a couple of places that you can get some technology help, like in the textbook or in the R guide. And then also want to practice saving an Excel file as a CSV file and then uploading that into R, right? So just getting familiar with a couple basics in R. Right. So first thing I want to do is I want to get logged into Canvas. All right, and then I'm going to go into course, and then go into modules. So I have this R module here, and I do have a link here for the R guidebook. So if you click on that, it will give you section by section of how to use technology in that section, right, where it makes sense. So the next section, 1.3, is the only thing in chapter 1 where we need R, right? So if you click on that, it tells you how to obtain a simple random sample. So it goes through and tells you how to do that, right? So in general sense, so this is how the code works. The command is sample, and then inside the parentheses you need to put the inputs in. So you're going to put the minimum number, colon, max number, and then a comma, and then the next argument is size equals, and then you put in how many numbers are in the sample, and then you hit comma, then you type in replace equals, and then either put true or false there in all caps, and then close the parenthesis and hit enter, and that's it gives you that solution, right? And then like here is an example of sampling without replacement, right? So we'll talk about all this stuff in the next section, but you just want to be familiar with being able to look at this is what it looks like in general, and then here is applying that to an example, right? So then the other item I want to show you is in the textbook. So let me open up the textbook. Alright, so let's go to eText. I'll go chapter 1, and I'm going to go to section 1.3 because I know there's some technology needed in that section. View the eText. So I'm going to jump towards the end. Alright. So the sections where it makes sense, there's going to be these technology step-by-step guides. Right? So in there, they show you how to do it on a graphing calculator. Minitab, which is a program that we're not going to use. You have to pay for that. Excel, and also StatCrunch. So I'll show you some things on StatCrunch. So StatCrunch is a statistical package that is created by Pearson, and it's free of charge with your MyMathLab access code if you have if you're using a statistics book. Right. All right. So now that you know where those resources are, let's practice what I was gonna say we're also going to practice. So I'm just going to take the data that we use in example 4 and save that as a CSV file. So let me open up the notes 1.1. Alright, so let's go to section 4. And this is the data table I was talking about. So I'm going to copy this. And now what I want to do is open up Microsoft Excel. Just do a blank workbook. I'm going to paste this in Excel. And then, so notice, we talked about like last section, this isn't a stacked, format where each row belongs to a person. We have variables at the top, right? That's what you want, for most cases when you upload this into R, right? That's the format you want it in, is that stacked format. So we already have it in that format. I can hit File, Save As, and then I'll hit Browse, and then I'll just save it to my downloads. But here you can call it whatever you want. Like maybe you want to call it your data, and then you can go select the file type. So we want CSV, which is this comma delimited. So this one here, right? And I hit save. So now it's saved in a comma delimited file format, right? Actually, I saved that to my downloads, but I'm gonna move that to my desktop, right? So I'm gonna go to my downloads, take that data folder, and I'm gonna move it to my desktop. Right, so I hang on, I need to close that. Alright, so it's on a different monitor here, but so you can see like there's the data file, right? So now if I open up R, and I'm gonna make the text a little bigger, so I just went to edit, and then the preferences, it was like GUI preferences, right? And then this window pops up. I'm going to use size, let's say 14, right? Make it nice and big, especially for the video. So now what you need to do to upload that file into R, the first thing you need to do is called setting up a working directory. So the working directory is essentially telling R where you want to where your files are, right? What do you want to work with? So the first thing I recommend is using the command get working directory. So get wd, and then you open a parenthesis and then close a parenthesis, hit enter, and that tells you where your current working directory is, and by default it's usually at your documents, right? So this is a file path, right? So like this is telling me I'm on my C drive, and then you go to the users folder. In the users folder we're at Tyler, and then these are my documents, right? So this is a file path. So I saved everything on my desktop, right? So I can say set working directory, open up a parenthesis, and then I'm going to copy this working directory where my working directory is right now. And then if you want it to be on your desktop, you just have to get rid of documents and say desktop, right? And then close your parenthesis, and then hit enter. And then so right now my R is looking or knowing that I want to work on my desktop, right? And something to mention is, notice when I hit enter, it doesn't say anything to me, right? That's a good thing. If something goes wrong, it will tell you. It will give you an error message, right? So for example, if I delete this P and hit enter, notice it gives me an error message. It's saying, wait a minute, we can't find that. So everything is, when you're coding, you have to spell everything, completely. It's very accurate, right? So I'm going to just add that P back in and hit enter. So that way my working directory is set back up where it should be. Now to upload that file, you're going to type the command read.csv, open parentheses, and then open quotes, and then you type in the file name, which I saved it as data, and use the file extension. It was a .csv file, right? And then close close your quotes, and then close your parenthesis and hit enter. And it's popping up, right? So there's my data. So I'm gonna hit this button and then hit that again so it pulls down, right? So I can see that data file. Now typically what you want to do is name that, right? So maybe you want to call it your data set. You could say equals and then read.csv, open parenthesis, open quotes, and then data.csv, close quotes, close parenthesis, and hit enter. So now what you've done is every time you type data set somewhere, you're referring to that file, right? So like if I type data set, hit enter, it will show me what's in the data set, right? And then you can do things to it, like you can type names, parenthesis, data set, and it will give you all the variables. So essentially pulling off that everything you typed in the first row, right? And so forth. So you could also do like mean of the variable female, and it will tell you the average value. Oh, it's saying object not found. I know why, because I forgot to attach the data, right? So R has the capability that I could have multiple files uploaded at one time. So to kind of balance that, you have to tell R which file you're working with at the moment. So it's called attach it. So I have to say attach data set. And now if I type mean female, it should work, right? So that's the mean value of female, right? Which actually that mean value really doesn't have any meaning, right? It's not really meaningful. Well, I can't. No, I don't really think that's meaningful. But regardless, that's how you can do that, right? So, for example, if I wanted to find the mean of the ages, I could type mean age parenthesis, hit enter. There's the average age in my data set, right? A little more meaningful, right? It's kind of weird to take the mean of female because remember 1 equals yes, 0 equals no. So in other words, 1's female, 0 is male. So that doesn't have any meaning, right? All right, so I think that's all I want to show you today. I'll show you some more things in R as we go through the term. All right, thanks.